Let's jump right in. Welcome to this explainer. Today, we're unpacking a seriously unusual pitch from an inventor named Georgopoulos. Now, if you look back at the audio landscape, especially originating around the late 1960s, the whole industry was practically obsessed with one thing: perfecting the acoustic chamber. Everyone was moving toward tighter controls, mitigating cabinet resonance, heavily engineered sealed enclosures, the works, right? But Georgopoulos, he stepped up to the plate and completely rejected the traditional rules of high-definition audio. He claimed he could redefine audio playback from the ground up by doing literally the exact opposite of what the prevailing science dictated. It's a fascinating pivot, and the way he presents this invention leaves us with some of the most wild engineering questions in the history of independent audio design. Let's look at exactly what he said to kick things off.
I mean, just listen to the absolute audacity of this opening claim. Make high-definition audio reality, which now it isn't. He isn't just trying to pitch us a slightly more responsive tweeter or, a cleaner crossover network. No way. He's operating on the premise that everything, literally everything, the industry currently considers high fidelity is fundamentally compromised. To any audio engineer listening, that is a massive line in the sand. We usually define HD audio by flat frequency response, vast dynamic range, and accurate transients. But Georgopoulos? He's out here asserting that all those methods relied upon by every major manufacturer in the world are basically just creating an acoustic illusion. According to his underlying philosophy, true high-definition audio simply does not exist yet, because our whole foundational approach to moving air has been flawed from day one. And naturally, his invention is pitched as the definitive cure to this systemic problem.
Which naturally begs the obvious question, right? How exactly does this invention work? If the entire audio industry has actually been relying on an acoustic illusion for decades, what specific mechanical secret is Georgopoulos leveraging to bend the laws of physics back in his favor? Okay, the mechanical contrast here is really the absolute heart of his design philosophy. Think about standard acoustic suspension or infinite baffle speaker designs. We know they fundamentally require boxes. They rely on these totally sealed environments or carefully tuned bass reflex ports just to control those rear-firing sound waves, manage air pressure, and prevent acoustic short-circuiting. You got to keep the front and back waves from canceling each other out. But Georgopoulos pits that conventional standard against his own open-air rebellion. His invention specifically works without boxes. It is, in his own words, not totally sealed. By entirely abandoning the traditional acoustic chamber, he is willingly giving up the mechanical damping and bass reinforcement that a sealed enclosure provides. In the realm of speaker design, this is literally like pulling the foundation right out from under a house, stepping firmly away from conventional mechanics and venturing into something much, much more radical. So let's unpack the physics of this physical anatomy, based purely on the specific clues he gives us. First off, he points out a modified driver. Next, we have a holder cover. And finally, and this is the absolute kicker, there's a hole there. This creates that deliberately unsealed environment we were just talking about. In practical terms, punching a literal hole into a driver's immediate housing completely alters its compliance and acoustic impedance. A traditional speaker relies on that sealed air acting like a pneumatic spring to control the cone's excursion. By introducing this precise opening, he's creating an unsealed environment that invites massive phase cancellation, especially down in the lower frequency ranges. It is a highly specific mechanical setup that acts a lot more like a complex dipole system. He's intentionally stripping away the acoustic enclosure, altering the electromechanical parameters, and deliberately letting the front and rear waves just interact in physical space. But wait, here is where the pitch takes a truly fascinating turn. You're looking at this revolutionary hardware, you're analyzing the implications of this unsealed dipole-like design, you are totally ready for the demonstration. And then he drops this line. If you want to hear it, you can't. I mean, what? It's kind of like a sports car salesman hyping up the aerodynamic profile of a brand new vehicle, sitting you down in the driver's seat, and then casually mentioning he took the engine out. It's just this bold, unexpected irony slapped right in the middle of a technical presentation. An audio pitch where the audience is explicitly told up front that they cannot actually hear the product. So the crucial point is exactly why we can't hear it. Well, he finishes the thought by stating it's because it has to have the right electronic equipment too. And for an audio-literate crowd, boom, that instantly connects the dots. The physical speaker, the unsealed driver, that deliberately introduced hole, is really only half of the equation here. Because an open, unsealed speaker loses massive amounts of low-end energy and structural damping due to that phase cancellation, this electronic equipment isn't just your run-of-the-mill amplifier. It is almost certainly a massive, custom, active equalization network, or maybe an advanced digital signal processing system designed to forcefully correct the frequency response.
This radically open mechanical design absolutely necessitates a proprietary electronic counterpart to artificially compensate for the missing box. Without that specific active EQ pushing extreme power into the corrected frequencies, the hardware is functionally silent. It's a totally interdependent acoustic and electronic ecosystem. The whole shebang has to work together. And if you really want to understand the sheer dedication behind this interdependent system, just look at the timeline. The copyright for the Georgopoulos invention originates in 1967 and extends all the way to 2026. Think about what that timeline actually represents in the audio world. Back in 1967, basic stereo audio was still just finding its footing in consumer homes, and solid-state amplification was only just taking over from vacuum tubes. Fast forward toward 2026, and we are living in this era of immersive spatial audio, crazy room-correcting algorithms, and incredibly complex DSP. To maintain a single proprietary acoustic philosophy through that massive technological shift, that is absolutely astounding. It represents a literal lifetime of unwavering dedication, refinement, and fierce protection of this very specific, unsealed hardware and custom electronic vision. So what does this all mean for us? Is this combination of unsealed drivers and heavy, custom electronic compensation the true missing key to high-fidelity sound? Or are we looking at a brilliant 60-year-long acoustic ghost hunt? We're left staring at a radical departure from traditional acoustic engineering, backed by a lifetime of dedication and punctuated by a brilliant moment of silence simply because we lack the right proprietary equipment to plug it in. It really forces us to wonder, is the perfect sound we're chasing genuinely locked inside a sealed box? Or have we just not plugged in the right equipment to harness the open air? Thanks for exploring this explainer with us. Take a close look at the speakers on your desk right now and keep questioning everything you hear.